Welcome to part 3 of my calculus series. Today we're going to be talking about derivatives. Now we already talked about this, whether you knew that or not, but that limit that we took to find slope was the definition of a derivative. And that's how you understand what we're looking for when I say, find the derivative. So the derivative is generally notated by d over dx, dy over dx, pardon. Now this is equivalent to another familiar something you've probably seen, and this is going to be delta y over delta x. D is just going to be our new notation. Some other notations we can have are going to be, let me see if I can find it. If I can't, it's not that big of a deal, but well, so you're going to have a d subscript x y, or that's another notation for your derivative. And probably one of the most common ways you'll see it is you're going to have a function f, and then you're going to have prime of x. All right, so these are going to be your common notations for the derivative. All right, now after going through all that work to find the definite, the long way to find the derivative, there are a lot of rules to talk about. So the first rule is going to be the power rule. All right. So the power rule is going to say that for any polynomial, we're going to have nx to the n minus 1. Now, what does this mean? So what this means is that if we have, say, x cubed, minus 2x, all right? So first of all, this right here is when we take the derivative of this, all right, we can take the derivative of each separately. Okay, so we're gonna have f prime of we have f prime of x. Really? All right. So this is going to be the same as f prime of x cubed minus 2 f prime of x. All right. So any constants associated with the variable, we can just take those out. All right, and we're going to separate these. All right, so this is going to be the derivative of x to the third minus 2 times the derivative of x. All right, now we're going to use power rule here. All right, so with power rule, this n is the current exponent. So this is going to be n. So we're going to multiply x cubed by 3 and then lower the exponent by 1. All right, so that's going to get us 3x squared. It's going to get us 3x squared minus 2 times, now for x, what we're going to do here is we're going to multiply it by 1 and lower the exponent by 1, which is going to be 0. So that's just going to be 1. So we're going to have 3x squared minus 2 as our derivative, and that is power rule. That is power rule. All right, now that we know power rule, there's some other fun stuff to talk about. So we're going to take the derivative of some trig functions. So I'm just going to write this out for your reference. All right. So the derivative of sine x is cosine x. Derivative of sine x is cosine x. Derivative of cosine x derivative of cosine x is negative sine x. The derivative of tangent x is going to be secant. It's going to be secant squared x. Now we know secant is 1 over cosine x. And then what else are we going to have? We're going to have the derivative of secant x is going to be equal to secant x tangent x, and our derivative of cosecant x is going to be equal to negative cosecant x cotangent x. And then we're going to have the derivative of cotangent x. Cotangent x is going to be a negative cosecant squared x. Alright, now that looks pretty messy, but it wouldn't let me do this the way I wanted to. So, but there are your basic trig ones. Some other weird ones for you. The derivative of e to the x. The derivative of e to the x is going to be e to the x. The derivative of the natural log of x is going to be 1 over x. Let's see here. Now the derivative of the logarithm base n to x. Maybe want to put a comma. Logarithm of n to x is going to be equal to 1 over, actually let's call this b. Let's call this b. It's going to be 1 over x times ln of b. So that's going to be some more weird ones, right? And yay, there's even more coming up. So not only are we going to have these beautiful things, we're also going to have derivatives of inverse trig functions. Alright, so these are going to be a pain in the butt to type, but here we go. So the derivative of arc sine x is going to be equal to, oh boy, it's going to be equal to 1 over square root of 1 minus x squared. Right. And then the derivative of arc cosine of x is going to be equal to negative 1 over square root of 1 minus x squared. And then the derivative of arc secant or inverse secant of x is going to be equal to, however, where you're going to have to add just one absolute value of x be x squared minus 1. So this is going to be for arc secant or inverse secant. Actually, I'm going to copy this. And then the derivative of arc cosecant, pardon that, and then of arc cosecant x is going to be equal to a negative 1 over absolute value of x, square roots of x squared minus 1. Oh boy, and then we're going to have the derivative of arc tangent of x is going to be equal to 1 over x squared plus 1, and then the derivative of arc cotangent of x is going to be equal to a negative 1 over x squared plus 1. So these are all the special identities you need to know. I'll give you a little bit of time to write these down because it's sort of annoying. So just pause the video and write these down because you're going to need them unless you memorize them already. Anyways, so now we're going to talk about chain rule. And this is going to be needed in later parts. So say we're going to have f of, I don't want this capitalized. Oh. We're going to have f of g of x. Alright, and this can really go on for a while. I mean, it can technically go on to infinity. So our derivative of this is going to be f prime of g of x. Right, so we're going to take the derivative of the outside. This will be easier to understand when I actually do it, but this is going to be f prime of g of x. So we're going to take the derivative of the outside and multiply it by the derivative of the inside. Right, so that's going to be our g prime of x. Just to give you an example. Alright, so say we're going to have sine of cosine of x. Alright, so our derivative of this is going to be, so the derivative of the outside is going to be cosine. So we're going to have cosine of the cosine of x. Then we're going to multiply by the derivative at the inside, which is going to be negative sine of x. This is also going to be equal to a negative sine x cosine of cosine of x. Alright, so this is going to be example number 1, the chain rule. So that's basically that. And now we're going to have the product and quotient rules. Firstly, the product rule is going to be, so if we have f of x, oh my lord. So if we're going to have f of x times g of x, the derivative of this is going to be f prime of x g of x plus g prime of x f of x. Alright, now I'll give an example for this one too. I'll give one that's like a combination of everything in a minute, but so we'll have this equation here. We're going to have, alright, so we're going to have, well, I'll make this pretty similar to the last one. We're going to have sine of x times cosine x. Alright, and this is going to be equal to, so we're going to take the derivative of the first, so that's going to be cosine of x times cosine of x, which I'm going to clean up here. This is going to be cosine squared of x. Cosine squared of x, and then we're going to add the derivative of the second, which is going to be negative sine x I'm going to clean that up too, so it's going to be a negative sine squared x. Not sine to the x, sine squared of x. Alright, now I'm just going to throw a trig identity in here. You don't really need to know these just for this overview, but it's going to be cosine of 2x. So now I'm going to give an example that uses all of these just to make sure that you get it. Alright, so now just so you know, these will apply. For example, oh, forgot one. Quotient rule. Quotient rule. So if we have f of x, and I forgot to put fraction. Alright, if we have f of x over g of x, our derivative is going to be, now this is usually, there's a song for this actually, but I'm not going to, I guess, get rid of your brain cells with it, but I'm just going to write it. So we're going to have low d high minus high d low over low low. Now what does this mean? What does this mean? So what this means is we're going to have g of x times f prime of x minus f of x g prime of x. I didn't want this to, whatever. G prime of x over g of x times g of x, or g of x squared. But so this is going to be our formula for quotient rule. So let's give an example here. So we're going to go, this is actually going to be a proof of tangent of x. Anyways, so we're going to have, you're going to have sine of x over cosine of x, which you should know is tangent of x from the trig section on here. So the derivative of this is going to be equal to, we are going to add fraction. Alright, so low d high, so cosine x, times the derivative of the top, which is cosine x as well. So this is going to be cosine squared x, actually. Cosine squared x minus high times derivative of low. The derivative of the bottom is negative sine. So we're going to have a negative, and a negative is going to be a positive. Then we're going to have a sine squared x. Have a sine squared x. Sine squared x. And this is going to be all over low low, or cosine squared x. Or cosine squared x. Alright, so this looks sort of messy, but you can really simplify this. So if you remember your Pythagorean identity, this is simply going to be equal to 1 over cosine squared x. Because cosine squared plus sine squared is going to be 1. Cosine squared x. Now if you remember, 1 over cosine x is secant, so this is going to be secant squared, which is what we said the derivative for tangent was earlier. So there's the proof for that. Alright, so here we have our proof for tangent, and I just showed you quotient rule. So now we're going to do one big combination. I'm going to come up with this out on the fly, so it's probably not going to be that good, but you should try to do it on your own. This is going to combine everything. So we're going to have sine of alright, I know. So we'll have sine of, this is going to be, actually, yeah, this is good. So we're going to have sine of x squared. No, actually, I want this in a fraction. This is going to be complicated, so I'm sorry. Sine of x squared times cosine of x over and we're going to do an inverse. We're going to throw an inverse in here too. Tangent inverse of x. And this is going to be our function. Alright. So, now this is going to be a beast of a problem, but give it a try, see if you can figure it out. So, let's do this. So, firstly, we're going to take the derivative of the outside, right, which is going to be cosine. Now I'm going to introduce you to u substitution. So we're going to call this whole inside this whole area here u, right? So we're going to say u is equal to all that stuff, all right? Now this is going to be f of u, because we have this u, not to be confused. Well, let me change this up a little bit. We'll have h of u, all right? We're going to have h of u times u prime, right, which is going to be the derivative of this inside, right? So first we're going to take h of u, right, which our h of u is going to be sine of u. So we're going to take the derivative, and this is going to be cosine of u. Easy enough, right? So now we're going to take the cosine of u, and we're going to multiply this by the derivative of this inside, which is going to be where the fun is. All right, so the derivative of this inside is going to use quotient and product rule. All right, so if you remember, low d high minus high d low over low low. Okay, so low d high is going to be tangent inverse of x times, now this is going to be product rule. So first times derivative of the second is going to be a negative x squared, because the negative of the negative sign, times sine of x, plus second times derivative of the first. So using product rule, we're going to have 2x. Oh, I forgot to mention, derivative of any constant is 0. Just keep that in your heads. So if there's that on any of the problems, the derivative of any constant is 0. Because, well, anyways. So we're going to have negative x squared sine x plus second times derivative of the first, cosine x, times 2x. Probably it's better to say 2x cosine x. Alright. Minus high d low. So this is going to be, now this is going to be a fraction. Alright, so this is going to be 1 over x squared, 1 over x squared plus 1. We're going to multiply this by the top, and we're just going to write this out because I don't have much more room. Let's write this out. We have x squared cosine x. Right? Now, all of this over low times low, which is going to be our tangent inverse I don't know how to write this. This is going to be our tangent. This is going to be, alright, this is going to be our tangent inverse Alright, there we go. Alright, so this is going to be our tangent inverse of x squared. Alright, so now we have our du, our derivative of the inside, and we have the derivative of the outside. Alright, now you just put all this together. Alright, so what are we going to have here? We're going to have, let's lower the font size a little bit so it'll fit on the page. Let's go 16. Alright, so now we're going to have cosine of, make this a fraction, of x squared cosine of x Alright, so we're going to have this. We're going to multiply this by this whole thing. We're going to make this section 16(2). Alright, so this is going to be our answer. Alright, so that combined everything. This is going to be way harder than any of the problems that I have on the website for practice, but if there's any part of this you didn't understand, you can just review this whole section and try to see what I did with the example problems for each. So that's part 3.